So we shall see what happened with Martin.
Yeah,
Thank
exactly. Even about XPath in the browser fully. My name is Martin. I'd like to talk to you about soft validation in our editor, FONTOXML. I'm a developer at FONTOXML. I've worked there since the very beginning, almost 3 years ago, I think. We all know what FONTOXML is, but I can imagine some of you won't be familiar with it. This is FONTOXML. It targets non-technical authors who are used to Word. We try to impersonate Word so that an author feels safe and can just work and keep on working, just like the older versions. It's very visible, nice. So if I place my cursor around here, this is our docbook editor, in which I wrote my paper. So as you can see here, it's quite easy to see. We've got save buttons, we've got clipboard buttons, we've got spell checking, and even more important, we can see how the structure looks of the document. We can see the source of the document. Most of the users don't really use it, but it's good for demoing purposes. And it feels really like Word. For instance, Ctrl-B makes a piece of text and emphasize piece of text. I now need to defocus the editor. Yeah. So let's now talk about schematron. I think most of you know what schematron is. Just to summarize it, it's a way of describing business rules over XML, which can't be expressed or shouldn't be expressed in XSDs. It's basically a set of queries for nodes and a couple of assertions and tests for business rules to assert it over it. For instance, this is an example schematron document. We have a paragraph, and all paragraphs should have a class. If a paragraph doesn't have a class, a message should be shown to a user, schema architect, essentially end user of the schematron engine. That paragraph should have a class. I'd now like to show you how schematron works in Fonto. For this, I've integrated the docbook schematron file, which is available on the docbook documentation website. And just one highlight of it, it defines footnotes should not be nested. So any footnote in a document should not have another footnote in it. I've integrated this in the Fonto editor, like this. If I now open if you open the editor, you can immediately see there's a small piece of orangey stuff. And when you click it, it shows you there is a footnote invalid. We can click on it, like this, and it scrolls into view. And we can immediately see this footnote is invalid. I've actually rewritten the schematron rule a bit. It defined all footnotes being invalid if they contain footnotes. I've written it the other way around to say a footnote is invalid if it's in if it has an ancestor footnote. So we can now see an author won't really understand these kind of messages. A footnote must not occur in the sentence of footnote. In the actual editor, we will prevent this, but just for demo purposes, I've disabled that. So I can now say, well, how to fix it? I don't know. The best way to fix all things is just delete it and gone. We now see no content issues, and everything is happy, everything is glad again. This is auto-saved, so it's done. I now need to defocus the editor again. Yep. In Fonto, we want to make everything live, everything as quick as possible. So an author doesn't have to wait, doesn't have to take actions or whatever to see what they are doing. They want immediate feedback. So one of our clients has over 3,000 generated schematron rules. 3,000 unique rules asserting something about an element. They all look roughly the same. Because we generated them, we can make them slightly more easy to evaluate. For instance, this one defines all chunks being an achievement kind of chunk. We're having a chunk body, and then look into the descendants, which are ordered lists, which are achievement lists. We assert there must not be any list items in it, not having a class. It's a bit a roundabout way of writing it, but it's basically the same. We can't run all of these 3,000 plus schematron rules every single keystroke, because every single keystroke may invalidate a rule one way or another. For instance, if I create a footnote here, insert, don't be scared about a huge thing. I'm gone again. We inserted the footnote here. The rules must be evaluated, so it can be solved again. We've got a couple of options of running all these 3,000 schematron rules at once. We can do them server-side. There's a slight delay, there's a server component, which we don't really like. We can make a huge update button for the user. So a user can manually check it, start a check, which takes about 5 seconds maybe, which isn't acceptable for every keystroke or any new element created, but it's after a button maybe. Or we'll do it live. Obviously, we chose the last options, because it's more awesome. For this, we need an export engine in the browser, because schematron rules can essentially be rewritten to export queries, matching all nodes which are invalid. For this, we implemented a export 3.1 engine, so that we can use it in other APIs. We use it for instance, how we set up commands. We can really use the maps and arrays features and those kind of things in the rest of Fonto. So how did we do it? In the earlier talk, we saw some other approach. We first parse an export expression, of course. For that, we used Pack.js, which is slightly different than Rex.js. The main features of the differences of it is that it defines another dialect for a grammar, in which we can choose to output AST nodes or choose to don't output AST nodes. It supports inline JavaScript for that. We then output an AST, abstract syntax tree. Since we're a JavaScript editor, we began as a JavaScript editor. We do it in JSON. For instance, it looks like this. This is the equivalent of the //node XPath. So we can see absolute path has a descent or self-axis, which contains a kind test, which is node. We interpreted it, and we transfer it to JavaScript objects. We save the abstract syntax tree in a IndexedDB, so we can cache them and can reuse them to mitigate a next parse hit, essentially. Also, Fonto comes back. Fonto users come back to Fonto, so we did it in IndexedDB, so it's saved and persistent over different browser sessions. Because the parser generator should be deterministic, it should always generate the same AST for the same expression. It's easily done. We then execute the export expression, which is basically parse the AST to different JavaScript models. We use it in a roughly object, an OO approach to it, object-oriented. We then resolve the functions, a small bit of static type checking. So when we reference the function access string containing one argument, we add to one. we map that to the corresponding function. If someone tries to execute the function access string with 5 arguments, we throw in a static error. So it's really easy. We propagate variables on a dynamic context, which we just pass around and wrap and scope and scope. So it's the engine currently, I just looked it up, weighs in at 160 kilobytes minified. That's 37 kilobytes minimized and gzipped. Dus it is a bit smaller. And remember, that's the compiling phase, the parsing phase, the executing phase, all of it in just one part. We aren't complete yet, we aren't spec complete. The main points we're missing is inline functions, which would be really nice, I really want those. And some other features which we don't really use, like access pattern. I haven't seen use case for pattern matching in XPath yet, in our implementation of it and our use of it. Because we only use it inside our own product. We don't market it as another product, so we can just do it. We need instant feedback. If an author creates an invalid structure, some way or another, for instance, there are some business rules we don't want to enforce so as hard as, for example, nested footnotes, like maximum character count in a title, maximum word count, minimum word count even. Valid date, it's really hard to write a valid date in one keystroke. So we want instant feedback for some things we do restrict, like too many elements of a certain kind. We have non-technical authors, so they don't want they won't be able to remember exact schema constructions, and they really need to be guided. So we go to the next part: how to do this whole thing live. We can do 2 approaches. Roughly what Section.js does, we just optimize the queries to death. But still, remember our client uses 3,000 unique expressions, 3,000 unique queries, which all need to be run at the same time. Or better, we can just run all the affected queries. Not all actions will invalidate the same rules. Some won't, like text insertions won't matter attribute validations on other levels. Attributes edits won't affect maximum word count, maximum character count, usually. So we built a simple dependency tracking configuration. We essentially capture all the DOM accessors, all the changeable DOM accessors, so not node name, of course. And when it happens, we record a dependency for the kind of change we have. So, for instance, if we look at a node's parent node, if the child list of the parent node changes, that relation could have been changed. For siblings, the sibling relation could be changed if the child list of the parent changed. For character data, the character data changed, the observed character data changed, if the character data of the node changed, etc., etc., etc. Same for attributes, same for all. We then used a DOM standard called mutation observers, which is implemented in our own DOM implementation as well, which has a couple of nice features we can use to see if a query invalidates or not, an XPath expression invalidates. We can look at the type, and we can look at the node, and essentially using those 2 items, we can see which queries have changed. It's a bit abstract, but of course, I've got a demo over here. This is some code we also host at xpath.labs.fontoxml.com, which is the sandbox environment we use for testing. But if we look here, the above expression is the simplified expression we saw a couple of slides earlier. I've removed all the attributes because it's a bit long and the resolution isn't that high. But if we look over here, yeah, I have made all the nodes which can be, which are in the result of this query, gave them a red background, and all the nodes which have been touched, which have child list dependencies, I've made them green. The gray ones aren't touched, aren't evaluated, because we can see here, in this XPath, we walk to chunk, we then walk to chunk body, we then walk to ordered list, and we then walk to list item. Observe, I've made this a direct child one, just for simplicity's sake. It runs, yeah, it runs. If we do this, of course, the paragraph might indirectly contain ordered lists, using some way or another. So just for simplicity's sake, let's do this. And we can immediately see, when we change text here, when we create elements here, like for instance a bold tag, it can't affect the result of the original query, because the original query immediately goes to introduction and then immediately goes to chunk body, so it ignores the whole introduction element. Because the schema we used 3000 schematon rules with looks roughly like this, so it's really nicely balanced. We can get away with it. Also, if this thing here included an attribute check, which I should do here, of course, and not on the other page. Something like this. We can see nothing matches, and we add the class on here. We can do this because this one was green earlier. We see it matches again. So it got invalidated by this attribute change on the top level. Are we done now? Not nearly. In the future, we'd like to involve some kind of static analysis, type analysis, partial querying, partial reuse of partial results. You can imagine if 7 XPath queries look at all footnotes in the document, we can reuse that partial result, even if it's transformed later. So we only have to traverse the whole document once. And in conclusion, the client is really happy. The client can type, the client can work, even with that insane amount of schematon rules. It has really good typing performance. We range at 30-ish milliseconds per average keystroke, and element changes, you don't even notice them. And also, the editor I just showed will be available next year for all speakers to write a paper in, because someone won't like Oxygen or whatever other editor. Fonto is slightly more of a non-technical author. I can imagine there are not a lot of non-technical authors here, but it's good to mix it up every once in a while. That's all. Are there any questions?
Thank you very much. So we have 2 minutes for question. So any question?
Over there.
Just over there. Okay, sit.
Thank you, sir. Pretty impressive stuff, and one can see other possible uses for this besides what you have in mind, actually. I can see this as being pedagogically quite useful. But I'm curious, in this very clever idea to ascertain which, oh, I'm sorry. First, I should just mention as a side comment that I don't think, besides little test schematron files, I don't think I have a single real schematron schema in my system that doesn't require regular expressions, pattern matching. But anyway, in this very clever idea of trying to find out which schematron rules might be affected by a change here, if the user types a character, you have and you're looking at the XPaths that might be involved with this character, but what are you comparing that against? The context node of the schematron rule, or?
Well, for every DOM access we do, for instance, we retrieve a child node from a given node, and then retrieve a child node from that given node, and then a descender from that given node. We introduce a direct child list dependency on the root node, a child list dependency on the node below. So it's all, we start from my context node, but then it just wraps around. It flows over, essentially.
So, but how do you decide, so given that you know now which nodes are involved, how do you say which schematron rule would be affected by this character and which wouldn't? You now know this area has these dependencies. Which schematron rules have those dependencies? That's what I'm asking.
For that, we just map. We save the dependencies on a schematron rule instance. We parse it and we transform it into JavaScript objects. And on that thing, we just save the dependencies. We loop over all schematron rules. We see, has this been changed, has this been changed, has this been changed, given the mutation records.
Right, and when you're looking at those schematron rules, you're looking at the rule's context attribute, or you're looking at every test and select attribute inside the rule?
We instantiate the schematron rules. We instantiate the schematron rules and the schematron asserts and schematron tests. We append the rules and the tests and the asserts into one huge XPath, and we save that on the schematron report instance, which can be invalidated, which can be rerun, which can do anything you'd like. Pleasure.
Thank you, Sid. Another question?
More questions?
Okay, thank you very much.
No. Thanks.